Good morning, everybody. Whoa, there's a few people awake. Hi, my name's Tim Nash. I'm the WordPress platform lead and developer advocate for 34sp.com. We're a web hosting company, and even though it says WordPress in my job title, that doesn't actually mean I do a huge amount with WordPress. I manage systems. I don't actually do much coding. In fact, the last time I wrote a PHP app was to update the talks here to make sure that all the examples ran. My day-to-day life, I actually tend to program in Python, Go, and Erlang, joyous languages, particularly Erlang. If you ever want to be a sadomasochist, come join us. But my original life was with PHP, and it's still my language of choice for doing things that I want to do on a personal level. As much as at work, it's poo-pooed. Today I'm going to be talking about writing CLI apps. And I guess one of the obvious questions is, why write one at all? After all, I'm guessing most people in the room do most of their work on the web. Is that a fair statement? Is there somebody in the room who has never written a web app? OK, cool. So most of you are probably working on the web day in, day out. Why write a CLI app at all? You're not going to suddenly change your minds and go, God, what I really want to be is a Linux system administrator and write really geeky apps. But CLI apps encompass a whole range of things. Everything from tools to make your lives easier. How many people in this room use Composer? OK, that's a PHP CLI app. How many of you use Artisan? Again, you're going to all put your hands up if you use Laravel. If you use WordPress, WP CLI. If you use Drupal, Drush, all of these are helper apps that can be used just to make our lives easier. They're all written in PHP. But CLI apps can be used for a range of things. How many of you have ever written a cron job? There we go. This week, you poor soul. We should talk about why cron jobs are evil and using job queues in a bit. But no, writing a cron job, it's a very simple CLI app. Just because you had no input, there's no user input, doesn't mean it's not an application and it's not for the command line. So you're going to have to do them at some point, so we might as well do them vaguely well. I'm not going to say brilliantly, but vaguely well. And PHP is actually not a bad application to do CLI stuff with. It's got a lot of tools, and more importantly, it can interact at the OS level quite well, because it's basically wraps around anything that NEC. And so we're going to be talking quite a lot about how to do things like exec calls to other applications and why you might want to do it. So I know everybody needs to be woken up. So for anybody who doesn't know how to run PHP on the command line, you type PHP and then the file you want. This is how high level we're going to go. So yeah, PHP, hello world, should execute. And whatever it's running in, it will say, command underneath as output. Now, depending on whether we thought about what we were doing, if we've got a bunch of, I don't know, we've set a bunch of cookies, we're expecting a bunch of server variables and stuff, this is going to look very different if we ran it on the web than if we ran it out. So if we're running it through PHPFPM or running it through mod PHP, we might get very different results than if we run it through the PHP command line. We could also do PHP-A and have a nice interactive shell, because who doesn't like to write code in a shell and then hit enter and go, oh, well, never mind. I didn't want that database anyway. We've all done it. But yeah, PHP-A gives you this a nice interactive shell. Remarkably, I find myself using the interactive shell. When I first saw when I was looking for the manual, and I saw it, I was thinking, no sane human being does this. They clearly cannot remember the 80s. If they're making us type things out manually and hit and go, no. But I use it all the time. I actually debug mail programs by just opening an interactive shell, quickly passing through arguments to fire off to a mail. Stuff like that, quick testing. For anything else, write a dirty script, run PHP, hello world. This is fine right the way up till we need to start building more complicated applications, or we have users. Users don't like us demanding that you put PHP hello and then put the file name in. Users don't want to know what programming language we're using, etc., etc. And by users, I mean everybody from your mum through to system administrators. In fact, a system administrator is more likely to be moaning than your mum is, because your mum won't understand it, unless she's my mum. She scarily does understand. So instead, what we could do is we can put at the top of our PHP file, hashbang, and this is pretty standard notation. I should have emphasized, while this is going to be talking about operating systems generally, it will mostly work for Windows, because it's Windows. But everybody else, it should work fine. So it mostly works for Windows. So we have hashbang, and basically we're saying we can either hard code in the exact location of PHP, or we can go user bin env PHP. And hopefully, as long as it's in the environment's in your path, this will work fine. Unfortunately, you can't really do one then opt for the other one, because you can't put the logic in, because this is basically running saying, hey, what should I use to find out the logic for the rest of it? So it's a bit awkward, because we can't tell it to just swap around. So we'll either hard code our path in there, or we put in hope that it's in the environment's PHP. And this is saying, use PHP to execute the rest of this file. The chain mod plus X is saying, execute this file. I've put it there as the very first thing, because I guarantee if you've never written a CLI app that you're going before, that you're actually just going to run without putting PHP in front, you will forget to execute it the first time. And you will scratch your head over and over again until you finally figure it out that you needed to execute it. But doing these two things means that we can now get rid of the PHP. So we can now just have hello world.php, and we can just run that. Excellent. Congratulations. This was the whole of this session over with. We don't need to do anything else. I guess you probably want to interact with it. Just a teeny bit. And the terminal is a fun and interesting place built in the 1960s with jargon that is very hard to understand 90% of the time, and by people who assume you know everything, or at least as much as they know, which as far as they're concerned is everything. So you end up with weird terms and lots of acronyms. So we'll start breaking some in. The first three big ones that you're going to hear is standard in, standard out, and standard error. Standard error is not what you think it is. If anybody just thought error, you're wrong. It just means something I want to tell you about or require you to do something. So standard in, stuff goes in. Standard out, stuff we're sending out. Standard error, the application wants to tell you something, which you'd think standard out would be that, but nope, standard error, application wishes to tell you something. And we can read standard in, do standard in, standard out, and standard error, just like we were handling a file, because that's what the Unix system sublayer is designed to do. But it does mean that we can do things like piping. So we can have one application sending it standard output, and we can pull that in, do something with that, push it along to the next application, and onwards and onwards. So if we want to read standard in, we can simply fopen it, and a load of stuff will appear, hopefully. If we want to talk going out, we can just echo new line \n. Alternatively, and a better solution, though we're going down in hopefully improvement, is PHP end of line. The reason for doing that is that's guaranteeing whatever OS you're on, it will return the correct end of line. Because while we're all used to seeing this, it's not the case for every OS. Whereas PHP doesn't, hopefully should know at least what OS it's running in and can return the correct end of line. If we want to write something out, so we can do standard out, new line, standard out, PHP end of line. When you're working in CLI apps, always write standard out. PHP may or may not be using standard out when it returns something to the screen. So where possible, always fwrite and do standard out that way. And we can interact quite happily, so we can prompt for what's the password, and then we can do read it in, and if we see what, say welcome, put whatever logic you like in there. Likewise, we can set it up to always be listening, so we can just have a while loop going with standard in, and we can do something based on whatever we're getting on a variable L. This is the basis for any good text adventure game, really. If you type in north, the function do something will receive north. It will have to process that and decide whether there's a giant python about to eat you. It's always a giant python, and it's always going to eat you. When it comes to your terminal itself, you will know virtually nothing, and PHP itself has no easy way to identify what's going on. You don't know how big the terminal window is, you don't know if it can support colors, you don't know if it can do, well, anything really. So the easiest way to use is a Unix application called tput, which you can call directly. Just bear in mind, tput is it's available on OS X, it will be available on FreeBSD and Unix-based systems as well as Linux. Windows, you have to be on the very, very latest version of Windows with all its Ubuntu subsystem-y stuff for this to work. So just keep that in mind. And obviously, when we're talking about applications, we tend to be talking about, I'll be referring to them as if it was local, but obviously these could be running on remote servers, in which case it's the remote servers programs you're talking to, not your ones on your computer. So tputs will give you columns and lines and colors, which basically tells you how wide and big the terminal is, and so you can frame whatever you're doing in. Colors. When I told you that they do archaic and weird things and all, yep, that is how you generate red. Of course, you all know all the other colors off by heart. And you can add house styling, you can also add underlining, etc. Nice little hint for you, if you're already using tput to work out whether you've got colors, you can actually tell tput to set the color. This has saved me years of knowledge that I no longer need to know about various colors in terminals, because I can just go set AF1, red. When I want to reset it, tput set AF0, back to default. When it comes to, so you may have noticed backticks in there. So I was making a call to tput, but because I had it in the backticks, basically I'm saying return this back as the return string. So call return string, X executes and returns the very last line. All of these things you will have been told are really bad because you're web people. But it's okay, you're at home now, you're back on your own system. Suddenly being allowed doing exec and shell exec is okay. Goto is still bad, sorry. But yeah, exec, execute and return the last line. Shell exec, execute and return the response, which is and then pass through is execute and return everything, whatever it outputted to the screen altogether. These two, at first glance, should look like they should be the same, but they're not, because what's considered to be about a response versus the junk it just produced is very different. When it comes to working and manipulating things on the command line, for PHP, we have the POSIX extension. POSIX gives you access to just about everything you can imagine. So if you need to know what directory you're in, what user is running, how to manipulate bits and pieces, there are dozens of commands. Again, this is something that normally you'd be going, boo, don't go near. Now it's fine. Now it's part of the standard normal way for interacting with a Unix system. I emphasize the word Unix system at this point because some of these commands will work with Windows, most won't. Within our application, I'm speeding through this, so I'm going to slow down for just 2 seconds and go. A couple of things to bear in mind if you are, I don't know, how many people in here use Unix or OS X by default in their day-to-day lives? Cool. For the Windows people, just so you know, your username and your user ID and your login can be completely different, and at any given point, your user ID can completely change. So if you're ever expecting to be checking for a user, check their GUID, so their user ID, don't check their login. That could be anything. So, with an application, we have, normally on the command line, you have whatever you're running, some primary inputs, and some additional arguments. How do we get these? After all, I can put any old string behind there. What might turn out? Well, thankfully, we've already got perfectly good methods for grabbing arguments. We can do argv, and if you're running the CLI SAPI, then argv will give you an array with any arguments that were included. It also includes the very first thing, the name of the thing you just called. So if you called hello world.php, the very first thing in the array will be hello world.php. Assume it's going to be there if you're doing that, otherwise you will be confused as hell. Particularly if you've written a command that deletes files, I strongly recommend you double check what you're deleting, and there are other options at this point. I hold my hand up, I've done that. I had a file that basically went through and deleted anything after it. It was a quick, dirty hack, and it just deleted itself. Nothing else. It didn't get any further than process one delete itself. And it could have been a lot worse when we'll talk about forking later, because I could have gone horribly wrong. So argv just gives you an array. It doesn't assume any information about that. So getopt is a handler. For passing options, it allows you to specify ones that are required, ones that are optional. And generally, and these are the things I actually care about, only return those to me. Do you know what? I don't use getopt very often. I tend to write my own handler if I'm acting it, which is terrible and bad of me to say, because it's not the correct way is getopt, but in reality I use argv, count the arguments with argc, and then write my own handler. I'm a bad boy. So let's make things simpler altogether. Having done that whistle-stop through, there are plenty of existing libraries to help manipulate and work with the CLI. The two that I've used and recommend, because I've used them, there are, I'm sure, hundreds out there and everybody will have their favorite. Symphony Console, which is actually really good. I think it's pretty much every of the major packages you can think of probably use Symphony Console. Certainly, I know CLI does, Composer does. I don't know if Artisan does it? Yep, Artisan does as well. Pretty much all of them do. If you want a slightly simplified thing, Climate, which is, it's okay. Obviously, you can ignore the extraordinary league part of that. But generally, it's a much more simpler one if you're just building quick applications. I used to say use Climate, but these days everybody uses Symfony, so I potentially suggest going there now. Certainly a lot more documentation written for Symfony. But it is a little bit more complicated. And it will let you do almost anything. It will let you render out to different formats, so whether it's JSON, whether you want to render out a table, a CSV file. It will also do things like progress bars. It will help you build a little interactive shell of your own that will only process certain commands. There's lots of functions inside there and lots of features. Climate really does go, hey, let's color your screen for you and give you a couple of outputs. But depending on what you need to do, that might be all you need to do. So we've got our PHP application. We've written a command line interface. It's all going wonderfully well, and we want to distribute it. We could just send somebody a zip full of PHP files. We could use Composer. We could use a range of things. But more and more common is to use a Phar file. Now, Phar files, you tend to see them more for CLI applications, but you can use Phar files on the web. You can have a Phar file as your main file on the website, and then just have an index.php file that requires the Phar, and off you go. Phar files are PHP archive files, and in no way was the idea stolen from Java. And if you were to look to who did Java, whether it was Java archive files or PHP archive files first, they don't win by about 10 years in there. But it's a good idea. It's basically taking an archive of a bunch of files, zip it up. You can use other compressions are available, but zip it up, include in there a manifest, include a stub file which basically says, hey, how do I handle all this stuff you've just shunted in here? And then deliver it. We've got one file which we can now distribute as much as we like. There are a few gotchas with it, but on the whole, a useful system. Creating a Phar file is really simple. You just have a folder full of stuff that is your source, have a folder where you're going to build, and then it's a really simple build script. Literally build this, do this, give it a name. What stuff am I going to put in? In this case, we're putting in the whole solitary one file, making this the worst idea ever. And then creates Phar has the ability to create a stub. So in this case, I'm saying, hey, create a default stub and put in the index.php. I'm just going to go back. And then the stub file that's generated is pretty much saying, hey, go load the index.php. And this is an important, the only other feature in there is this halt compiler. Don't do anything else. You can start reading the standard input and output because they're separate, but don't run anything else after this point. There's loads of additions you can make to that file, but that's the most basic. And it's generated automatically when we have this create default here. And then interacting is simply require once, name a file, plonk in your other file, or if we want to just include the default that would then generate from the stubs, that would be, in our case, index.php. We can do that below there. So a couple of gotchas. By default, on every single system known to man, Phar.read-only is set to 1, which is exactly what it says. It's read-only. This is intentional. Phar files should be read-only. The only people who should be changing Phar file from read-only to 0 are people who are creating Phar files. Otherwise, we lose all the usefulness of them, and certainly a lot of the security aspects. But again, it's one of those things that the first time you do it, you'll forget, and you'll sit there and go, why? This error message, and the error message doesn't explain. The error message says failed. Yeah, thanks. The other thing is you can specify compression, and by default, the compression is set to gzip, which is fine, till you use Windows, and gzip's not installed, and it's not fine. So if you are worried about such things, you might want to switch it back to zip. It's okay. So far, I've pretty much said it's Windows. I think for the rest of the talk, I'm just going to assume that none of what I'm about to tell you is going to work on Windows. Because everything we're going to talk about next is very dependent on the OS you're using. Because we're going to talk about threading and forking and the slight differences and why we don't want to do. So we're going to start with a safe way. Threading. Throughout history, PHP has a terrible reputation for forking, which we'll come on to, and the fact that it didn't have any real threading. Though I'm pretty sure pthreads has been around for about 10 years. So I'm not quite sure why anybody believes that it's not had it for this period of time. But yes, certainly it's made massive improvements in PHP 7. The whole thing got rewritten. So threading basically works like this. This is the most complicated thing you're going to see today. So we have a class that gets extended. We have a bunch of workers, and we have a pool, and we say, hey, workers, go do job. And they go do job. It's that simple. The difference, though, between threading and forking is the threading is we're making use of POSIX threads. We're not changing the actual process ID, and we're not generating new process IDs, which is sort of important. So we can't, with pthreads, you shouldn't be able to zombify your workers. You shouldn't be able to zombify your workers in there. Because pthreads isn't available on absolutely every system, though pthreads does work on Windows, there is a polyfill. So you can actually run the polyfill. Now, this will fake pthreads. It's actually not doing anything in parallel. It's doing it singular, but it won't crash out the complete system. So if you're building an application that you don't know whether or not it's going to have threading enabled, add the pthreads polyfill. That way, the worst case scenario is your application is not running in parallel, it's doing it singular, one at a time, but it hasn't crashed. So, now for the daemon bit. Forking, aka demonizing. On Unix systems, running things as daemons is perfectly normal and sensible thing to do. The idea is that we have a parent, and then we spin up, when the parent actually does something, we go, well, I'm not doing all that work. God, no. I'll spin up some children. And my children will go and take over my life and do my jobs. That's what children do, right? Oh dear. PHP is notorious for its forking. This is, again, partly down to people trying to fork things on the web, and I should have put that with a big warning. Pthreads and forking, I wouldn't recommend doing if you through something like PHPFPM or mod PHP. Pthreads are a lot safer than they used to be. This is a good way to find your system dead. When some kind folk on the web finds enough of an exploit to go, oh look, I can start forking children. Millions of children. Never-ending stream of children. Oh dear, your system died. What a shame. Bye. So on the command line, it's a little safer. A little safer. So this is a really simple example, and all it's showing is that we fire off a fork, and we say, hey, Daddy, what's your process ID? So we get out one process ID, and then we write out, hey, I'm a child now. Oh, I've got a new ID. If we then expand that out, if we have an array with a bunch of tasks, we can then go and say, hey, let's fork out all those tasks. Give the tasks to the children. Children, go complete your tasks. Unlike threading, where we have absolutely no idea what our children are doing with forking at this point. They might be dead for all we know. No, literally, they might be dead. We have no indication. Nothing comes back to us unless we deliberately ask for it. So we have to assume our children are dead unless we can communicate with them some way. So we go through, we execute our tasks, and we sit here waiting, praying something is finally going to come back. Once we've got all our statuses back, off we go and carry on doing something. We can execute whatever we like in these points. Using threading and forking on the command line is fairly safe, as long as you remember to do things the standard way. When a forking falls down, where PHP gets its notorious reputation for these things, is when nobody goes, oh, wait, Unix systems have been doing this for nearly 50 years, perhaps we should pay attention. And when they give us actual signals to tell us how to terminate things and know where our children are, perhaps we should listen to them. Oh no, I'm going to write my own handler. So as long as you use the basic functionality that exists, it's not too scary. Which leads to the final slide, and I have raced through, so I apologize, and I will we'll have lots of space for questions, I'm afraid. But the final slide is really break the rules, because all the rules you were taught, most of the rules you were taught about security go out the window. Once you're on the command line, security becomes, I was going to say less of a concern, but it becomes more of a concern because you can do everything. And the CLI apps, most web interfaces and web servers will be locked down. People don't lock down their terminals. You might be jailed, if you're lucky, but plenty of people run this stuff as root. Please don't run things as root. Please don't run things as root. In fact, here's a hint. Go and find out which user is running the process, and if it's root, say, no, I won't do it. There are plenty of applications that do that. I know CLI actually has a really good one, which basically goes, no, if you want to do this, we're going to make you add an additional parameter called allow root. And originally, when you did that, it went no. Alas, they have changed it, and it does now allow you to do things as root. But yeah, bearing in mind, if you run that as root and there's something, anything can happen. So make sure you understand that you are, when you run that application, it's you as the user. When the cron tab runs the application, it's the cron tab's user that is running it. That's important. It's exactly the same on the web if you think about it, but the difference is that normally it's on the web, if it's mod PHP, it's the Apache user who is running that script. And if you're using PHP FPM, it's whatever been assigned in the pool's user to run that script. Same things. So keep that in mind. Make sure, because when somebody runs from a CLI, chances are they have way more power than they're used to. Do use threading. Is that 1 or 10 or 30 or 30? Wow, this is going to be a very long breaking the rules section. Okay, so yeah, I've completely lost my trail of thought. Yeah, so you have the ability to do whatever you want. That's brilliant, because it does now give you complete freedom to write any sort of application you desire. It means that you have complete control over the OS if you have appropriate user levels to have complete control over the OS. So no longer is PHP this thing for generating websites. It's for doing anything you like. It's amazing how many sites get hacked, and the first thing they do is put shells on. Just because even with a limited user, you can cause chaos. So keep that in mind, just when you're writing your applications, that you're not going to cause too much chaos. Don't be afraid to make use of threading. Don't be afraid to fork. Just do it sensibly. It's what the Unix system was designed to do. PHP is not great at it, but it's not the worst. And actually, Python's forking implementation is terrible. And their threading implementation is non-existent. So just bear that in mind, that you've got these tools available to you. The command line itself can be seen as very antiquated and old, but in reality, it's probably the best user interface for most people in this room. I don't know about anybody else, but for me, my life is sitting on that interface. I find using a mouse very annoying. I don't like clicking things, except this. Even this, this has 4 buttons and I can just about code. But yeah, the CLI for me is a place that I can work in very, very quickly. I've got used to being able to do tab auto-completion. I've got used to just being able to run things quickly. I'm used to seeing standard error messages that actually look the same. By the way, the first person in this room who decides that their error message is going to be yellow, go throw yourself off the building. When you build your applications, keep that in mind. Keep that it is a pretty standardized place. People don't like flashy graphics. People don't really like ASCII art. Okay, most people like ASCII art. But people don't like ASCII art when they're not expecting it. And the biggest advantage to using the CLI and using standard inputs and standard outputs is it can interact with other applications. So make it possible to interact with other applications. Because if you don't, instead of doing a standard out with a sensible message that can be passed, you decide to do some ASCII art, your boss is going to hate you when you go, well, actually, it would have taken us 2 seconds to just pipe that through to that application. But I have to rewrite it to remove some silliness that I've put in. Keep in mind that your applications are also going to be used by things that are probably not humans. So if you've written a beautiful table full of tabular data and it looks very pretty, make sure there's a CSV or a JSON output. I mean, you can put a CSV in, but that's going to, or an Excel, or whatever you know that it's going to be manipulated by something else. And that's it. And I don't think I've got 30 minutes. I think I've got about 20 minutes for questions as I've raced through. So does anybody have any questions? Thank you. I need water. Is there any water? No? Okay. Yes. Go, Kat.
You spoke about tab completion.
Yes.
Is there any way from your client app to be able to give back autocomplete options?
Honestly, I tend to put autocomplete stuff into my bash profile, so I don't know is the quick answer. Does anybody know? I think because of the way that the individual shells work, they all interact slightly differently, and their autocomplete is slightly different. So
You'd have to provide like bash. You'd have to provide bash,
exactly, yeah.
and then get source.
And then you'd have to do that for ZSH and for all the various ones on there. So, though most shells do support bash autocompletion. So I think what you can do is if you write your documentation in the right way, you can have that, so at least it gives you some sort of help prompt. But no, I don't know of an easy way to do it. That would be really cool. So the application itself automatically registering the tab autocomplete. That's what I think you meant. Yeah. No, I was going to say I don't think I've never seen something do it. So it would be super cool if it could, but I could also see why it would be super annoying.
It's mostly provided if, like, if you're in a package manager,
Yeah, would have the bash. Yeah.
Application and the bash completion script to go with it.
You can get the so the far if you're using a Phar file, you could actually set it up so that because it can manipulate the environment variables as part of the stub when it opens. So there's a small chance you might be able to do it there, but I think someone would get really upset with you if you did that because you'd no doubt ruin a bash file somewhere. Any other questions? Yes. Oh, cool. Yes, I love cron jobs. Cron jobs are brilliant, except for the fact that cron jobs provide you with no useful information back unless you provide it. The other thing about cron jobs is that cron jobs run in parallel. No, they don't. They run in series with each other, so you can end up with your cron job being stuck, and then the next thing in your series having trouble going through. But it's the lack of feedback and the lack of control over them. Basically, you've set a timer, and that's it. Whereas if you had a queue and job management system, which still fundamentally might rely on a cron job at the very end, you at least have the ability to say, hey, I've asked for this job, I'm now locking this, so I now know that this job is in process. Here is the feedback that's coming through to it. It's executed, I can now run these ones in parallel bits. Thank you very much. It gives you a humongous amount of control, or a humongous amount more control than simply a cron job, which is a fire and forget thing. So I'm not against the principle of a cron job, though I'm one of the very rare DevOpsy people who actually doesn't mind systemd. Cool, no one's tried to kill me. That's amazing. If I'd said that anywhere else, I suspect I would have been massacred on the spot. So who doesn't mind systemd? And systemd has one of the newer features in that is something called timers, which will ultimately, for most Unix systems, may replace cron jobs if somebody would actually give them half a chance. And they provide a lot more feedback, and you can do chaining off them. So you can say, here's my cron job. If it hasn't finished in an hour or two, can you find out why and do X, Y, or Z? Or if it's not finished in an hour or two, can you go and constrain it in some way? The other issue with cron jobs is that unless you've put some constraints onto them, so they can end up just using up all your memory and CPU usage. So by having a bit more control, you can say, actually, I want that job to run, but I don't care about it. So just run it when you can and throttle the CPU usage on it versus I want this job and it has to run. And a cron job has no way of knowing the difference. The cron tab just runs stuff. That make sense? There is nothing wrong with cron jobs. Anybody else? Yes?
Any comments on using React PHP for CLI applications?
I have not used React PHP at all. It's one of those projects I always look at and go, I want to play with that, and I never find a use. But yes, I would have imagined it's actually perfect for running in a CLI project. But yes, as I've not actually used it, I can't give any if it's good or bad to use, but it is certainly a project that I've looked at so many times and gone, I must find a use for it.
It's used in Fergie, the PHP IRC bot. So that's a reasonably good example of
Yeah, I mean, has anybody in the room used React PHP? Yay! Would you recommend it for? There we go. There we go. Give us Can you give us like the 30-second pitch on why you would?
React PHP allows you to react instantly to incoming things. For example, you can set it up and just say, okay, if user input comes in or if the signal gets registered, you can say, okay, do something. For example, it allows you to react to individual key presses. So you can make really interactive games, for example, or CLI applications, chat applications.
I point out that the standard line in will do. You can work out what key presses were done. So, but no, that's really cool. Yeah, I need to play with it. Is the quick answer. Any other questions? No, I've got 15 minutes. Go on.
With how you said about communicating your child processes, and your example basically had the same one line of code.
Yeah, it was a pretty terrible example of a group. For the forking, you mean, or for pframes?
Yeah.
For forking, I mean, when forking, it just because the file, because it's actual processes, not separate files that are running. So as it comes through, it kills off. It's by checking what PID we're running, it determines whether or not it's doing this task. So it basically reloads the entire script again. Goes, hang on, what PID am I? Okay, I'm not the master PID, so I should be doing the executing thing in here, and then processing through.
So does the ECMTOR fork create the new fork?
Yes.
As well as return the current PID?
Yes, so it knows, so that the PCNTOR fork knows is the thing that generates the PID for each process that's going through, and it identifies that it's not, when it got generated, when it gets generated, it will recognize that it's not the parent, and therefore will process through that while and execute as it goes through. I have a better example, which I can, oops. I know. We'll just stare at daughter. Yeah, I've got a much better example of actual code that I've written that I will dig out and I can send across. But yeah, the fact that it was in one file is irrelevant because it's actually it will always process from the same point, which is a bad thing because you're basically doubling your memory usage every time you have a new child. But again, I'm not going to say you don't care about memory usage when you're on the command line, but it becomes less of a constraint. The only thing to do is to remember to kill things off, and make sure that you kill off your applications properly. And if you're going to exit at any point with an error message, please set, if you have an exit or a die command, just send over the data 0 because you've not intended to go out, and kill things off properly so that any application that's following knows that you didn't actually intend to come out. I think we actually now have time for one more question. So make it a really good one. That's complicated. And puts me on the spot, so I don't know the answer. Yes?
Do you have any tips for keeping processes running for really long, like years?
Years? Don't, yes. No, I mean, actually that is the correct, the answer is don't. Make sure your process can resume from wherever it left off is a much better solution. So rather than worrying about how long is my process going to live, worry about how easy is it for my process to resume. Because in any operating system, you have to assume that your application is going to die. And that you do not have, and you as the user very rarely actually have the complete control over a process. Along the way, there are plenty of other things that can interact and cause that process to die. Not just somebody doing a kill -9 command. So I'd worry less about keeping it alive and more about how do I know what state it's in and resume it. Yeah.
System's running, and if you die, then it will get re-triggered within a couple of cycles, and you pick up where you left off.
Again, if you're on a modern Linux system and you're running systemd, creating a systemd unit, you can specify with the systemd unit that you want it to stay alive, and then systemd will automatically restart and reprocess it. The other advantage to using something like systemd over supervisor is that you can specify, hey, I've died, 1 minute. That application I rely on, is it running? Yes, okay. Make sure that I can only be started if that application started, so you have to go and restart me, and you can build chains. Monet and supervisor D are the two common ones for keeping stuff alive and making them restart if there's a problem. And they normally work by saying, hey, if you go to here or you do X and nothing happens, then restart me. So for Monet, you can do. Monet's really useful actually if you ever. How many people in the room ever ran HHVM? Yeah? Now, HHVM was fantastic except for one small tiny thing, which was it was the constant memory leaks that it seemed to have. And every single solution to this was not, hey, maybe we should fix the memory leaks. It was set up Monet. And Monet was basically paging the home page of your application, and if it got a 502, it just restarted HHVM. That was the official answer for how to fix memory leaks. You could do something similar. If you're expecting a daemon and you know what your process ID is, you can tell Monet, hey, I need this process ID should be running. If it's not running, restart me. Within the application itself, all those sensible things you'd expect, so keep your memory usage low, keep an eye on your memory usage, make sure you're not doing anything, and if you are going to spawn your children, don't kill your parent. You laugh. I've done it plenty of times. But yeah, ultimately, the application isn't in control of itself and it won't know if it's dead. So have either a third party do it, or better still, just assume you're going to die and write your code with the assumption that you're dead. That's a nice, happy way to end this talk, isn't it? Write your code on the assumption you're dead. That's probably that's going to be my new motto for life, because that covers everything from write good documentation, write code that doesn't suck, write code you're not worried that someone's going to see when you're dead. Yeah, no, I like that. Thank you very much. If you do have any other questions, I will be around for a little bit. Please come and approach me. Thank you.